Hi everyone. Part 2 of the lecture for Building an Intelligent World with the cycle of IoT, Cloud, Big Data, Artificial Intelligence, and IoT. In the Part 2, I'll address Big Data, Artificial Intelligence, and a cycle of IoT, Cloud, Big Data, AI, and IoT. Then finally, I will discuss the building an intelligent world, right? From the views of intelligent digital transformation and convergence of AI and ICT for intelligent service, right? The coming flood of data. According to Intel, by 2020, this year, average internet user will be 1.5 gigabyte of traffic per day will be produced. And autonomous vehicles will produce 4 terabytes of data per day. And connected airplane will produce 5 terabytes of data per day. Smart factory, 1 petabyte of data per day. And cloud video providers will produce 750 petabytes of video per day. The tremendous amount of data are produced.
We all use smartphones, but have you ever wondered how much data it generates in the form of texts, phone calls, emails, photos, videos, searches, and music? Approximately 40 exabytes of data gets generated every month by a single smartphone user. Now, imagine this number multiplied by 5 billion smartphone users. That's a lot for our mind to even process, isn't it? In fact, this amount of data is quite a lot for traditional computing systems to handle. And this massive amount of data is what we term as big data. Let's have a look at the data generated per minute on the internet. 2.1 million snaps are shared on Snapchat. 3.8 million search queries are made on Google. 1 million people log on to Facebook. 4.5 million videos are watched on YouTube. 188 million emails are sent. That's a lot of data. So, how do you classify any data as big data? This is possible with the concept of 5 V's: volume, velocity, variety, veracity, and value. Let us understand this with an example from the healthcare industry. Hospitals and clinics across the world generate massive volumes of data. 2,314 exabytes of data are collected annually in the form of patient records and test results. All this data is generated at a very high speed, which attributes to the velocity of big data. Variety refers to the various data types, such as structured, semi-structured, and unstructured data. Examples include Excel records, log files, and X-ray images. Accuracy and trustworthiness of the generated data is termed as veracity. Analyzing all this data will benefit the medical sector by enabling faster disease detection, better treatment, and reduced cost. This is known as the value of big data. But how do we store and process this big data? To do this job, we have various frameworks such as Cassandra, Hadoop, and Spark. Let us take Hadoop as an example and see how Hadoop stores and processes big data. Hadoop uses a distributed file system known as Hadoop Distributed File System to store big data. If you have a huge file, your file will be broken down into smaller chunks and stored in various machines. Not only that, when you break the file, you also make copies of it, which goes into different nodes. This way, you store your big data in a distributed way and make sure that even if one machine fails, your data is safe on another. MapReduce technique is used to process big data. A lengthy task A is broken into smaller tasks, B, C, and D. Now, instead of one machine, 3 machines take up each task and complete it in a parallel fashion and assemble the results at the end. Thanks to this, the processing becomes easy and fast. This is known as parallel processing. Now that we have stored and processed our big data, we can analyze this data for numerous applications. In games like Halo 3 and Call of Duty, designers analyze user data to understand at which stage most of the users pause, restart, or quit playing. This insight can help them rework on the storyline of the game and improve the user experience, which in turn reduces the customer churn rate. Similarly, big data also helped with disaster management during Hurricane Sandy in 2012. It was used to gain a better understanding of the storm's effect on the east coast of the US, and necessary measures were taken. It could predict the hurricane's landfall 5 days in advance, which wasn't possible earlier. These are some of the clear indications of how valuable big data can be once it is accurately processed and analyzed. So, here's a question for you. Which of the following statements is not correct about Hadoop Distributed File System, HDFS? A. HDFS is the storage layer of Hadoop. B. Data gets stored in a distributed manner in HDFS. C. HDFS performs parallel processing of data. D. Smaller chunks of data are stored on multiple data nodes in HDFS. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. Now that you have learned what big data is, what do you think will be the most significant impact of big data in the future? Let us know in the comments below. If you enjoyed this video, it would only take a few seconds to like and share it. Also,
Now, big data meets cloud computing. Big data loves cloud computing. Without cloud computing, there's no big data. So, requirements and capabilities of cloud computing for big data. Data collection, data pre-processing, data storage, data analysis, data visualization, data management, data security, and protection, right?
Why cloud computing is enabling the big data economy. We've had big data for many years. What we didn't have was the ability to actually store and analyze data. And with cloud computing, all of this changed. In the past, companies basically had to hold their data in their own data centers. So they had disks of data, and the more data they had, the bigger the disks became. And if you wanted to analyze it, you actually had a physical reader who would find the data and process it, and this gave us huge limitations. One company that was instrumental in creating what we now call distributed computing was Google. Google basically wanted us to search the internet in a split second. They couldn't store the entire internet on a disk and then find the relevant information. So what they have come up with is storing bits of the internet on computers anywhere in the world, and then having these connected via the internet, you then break the analysis up. So if someone wanted to search for the internet or a specific bit of information on the internet, Google's intelligent software would then know where the data sits. It would break up the analysis, so use little servers, sometimes hundreds of thousands of servers, who would all perform a tiny fraction, but in parallel. This would then all be aggregated up, and in a split second you can get the result. Nowadays we use cloud storage and cloud computing all the time. So if you have an Apple phone, for example, you might use the iCloud to store your photos, and this is exactly what we do. We store the photos on the cloud. We don't actually know where this cloud thing is, but it's probably a server. Quite often there's some redundancy, so we have you have your photos on multiple servers across the world, and if you want to look at it, it simply downloads it over the internet onto your device. And this is what companies now do. Nowadays, it has broken down all the barriers to data storage and all the barriers to data analysis. So a company like Walmart, for example, which generates 2.5 petabytes of data every hour, they can simply go to companies like Microsoft or Amazon and say, please give me 150 petabytes of storage. They say, here you go, and then they stream their data to them. The other thing they do is they will give you the ability to analyze this data in almost real time, so we don't have the time lags. In the past, when you had huge data centers, sometimes you wanted to answer a question and these processors would crunch overnight and you come back and you get the answer. Nowadays, this is done in real time. So if you, for example, use your iPhone, you say, hey Siri, where's the nearest Starbucks? What happens is that your phone records this, it then sends it via the internet to a cloud server, it will understand what you've said, it will then trigger a search on the internet to find the nearest Starbucks using GPS information and other things, and then send the answer back to you. This involves over 100,000 computers, but takes 0.5 of a second. So this is what cloud computing is all about. It means any company can now store nearly unlimited amounts of data and can analyze this data in real time to drive performance improvements. If you would like to learn more, head to my website at bernardmar.com, where you can find tons of articles, white papers and videos that will give you a lot more insights into real-world case studies and examples.
Definition of big data: a paradigm for enabling the collection, storage, management, analysis, and visualization, potentially under real-time constraints of extensive datasets with heterogeneous characteristics. Paradigm is used here to express the necessity to find new approaches to address identified issues and phenomena. Examples of datasets characteristics include high volume, high velocity, high variety, and so on. 4V definition. Definition of big data has evolved from 3V, 4V, and 5V. Right? And 4V is the most popular definition. So 4V includes volume, large amount of data from various different kind of data sources, including IoT devices, right? And velocity, the speed, the data streaming data, real-time data, and the variety, all different kind of data, including unstructured data, structured data, and semi-structured data for many different applications. And veracity. Veracity as the quality, output quality of the data, right? So some people use 5V by adding value on top of this, right, to define big data. So everything and everyone is generating data. Consumer equipment providers, consumers, ICT infrastructure providers, regulators, logistic companies, public transport companies, city authorities, manufacturing industries, hospitals and doctors, insurance companies, appliance providers, facility management, retail stores, application developers, utilities, automation equipment providers. This all provide and generate data, right? IoT is actively driving digital disruption from social, mobile, big data, the cloud. Data is accumulated unconsciously by the connected things. So IoT is building connected things, generate tremendous amount of data, right? It's really driving digital disruption. Now, the big data and IoT in reality. Big data is about data, plain and simple. Yes, you can add all sorts of adjectives when talking about big data. But at the end of the day, it's all data, right? And IoT is about data, devices, and connectivity. Data, big and small, is front and center in the IoT world of connected devices. IoT Big Data. IoT generated data is getting bigger than social and transactional data. It becomes majority of data, majority of big data, right? As we are moving into hyper-connected society, right? More and more devices are connected and generate data. It's called IoT Big Data. IoT Big Data characteristics. Some analysts indicate that by 2020, 40% of data will come from sensors and IoT devices. Multiple data sources, real-time data from things and context, historical and social data. Data are mainly semi-structured and unstructured. Data may have different precision and confidence levels, right? And various operations to be made on data for the extraction of actionable intelligence. Target the right data at the right time at the right location. Now, challenges of IoT big data include huge data volume, difficulty in data collection, incomparable standards, new security threats, no reliability in the data, fundamental shifts in business models, and huge amount of data to analyze, a rapidly evolving privacy landscape, right? These are important challenges of IoT big data. IoT big data has a big opportunity. The intersection of IoT and big data is creating a tremendous business opportunity. But the reality of today's IoT projects is that this potential has yet to be fully tapped. For people, self-organization, better experiences, and intelligent environment. For business, converting products to services, expanded value chains, new business models. For industry, next chance to change the world, the step towards Internet of Everything, and completely new markets, right? This should be addressed, right? To capture the big opportunities. Now, IoT data transformation. First, things generate raw data, and additional information enables creation of structured metadata, and abstractions and perceptions give detailed insights by reasoning using the knowledge. Right? And finally, actionable intelligence allows decision making with this wisdom. Right? Using and monetizing IoT data via analytics. Data analytics are key revenue opportunity in IoT market. Data analytics can allow organizations to drive revenue by sharing, analyzing, and interpreting data for multiple purposes. Right? And surveys indicate increasing big data analytics deployments and exponential growth of big data analytics revenue. Now, what makes IoT analytics different? Basically, more data and more complexity and more automation, right?
Picture this, a machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, it picks up the keywords play and Despacito, and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means, through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that by the year 2045, we would have robots as smart as humans. This is called the point of singularity. Well, that's not all. In fact, Elon Musk predicts that the human mind and body will be enhanced by AI implants, which would make us partly cyborgs. So, here's a question for you. Which of the below AI projects don't exist yet? A. An AI robot with citizenship. B. A robot with a muscular skeletal system. C. AI that can read its owner's emotions. D. AI that develops emotions over time. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. Since the human brain is still a mystery, it's no surprise that AI too has a lot of unventured domains. For now, AI is built to work with humans and make our tasks easier. However, with the maturation of technology, we can only wait and watch what the future of AI holds for us. Well, that is artificial intelligence for you in short. Do not forget to leave your answer to the quiz in the comment section below. Also, like, share, and subscribe to our channel if you enjoyed this video. Stay tuned and keep learning.
Now, changes of successive waves of artificial intelligence as time passes from assisted intelligence to augmented intelligence and to autonomous intelligence, right? So for assisted intelligence and augmented intelligence, mainly given by narrow artificial intelligence. Weak AI or narrow view AI. Autonomous intelligence as related to strong AI and generalized AI, right? Now, AI enables intelligent IoT. IoT devices produce or generate data and store it over the cloud on the big data umbrella, and data over the cloud are analyzed by artificial intelligence, right? And for the intelligent service, the commands are sent to actuators on the IoT device, right? Now, with sense and reasoning, we can have context awareness, and with knowledge representation and inference, we can have smart data, and smart action can be taken by sending a message or command to actuator, right? So this is a cycle, right? Between context awareness and actuator, AI, basically machine learning algorithms are in between, okay? A cycle of IoT, cloud, big data, AI, and IoT. From IoT device, data is generated and collected and stored over the cloud computing, right? And accumulated data is analyzed on the big data umbrella with artificial intelligence and machine learning algorithms. And for intelligence service, a command is sent to IoT device, right? Then we can have intelligent IoT service. And this service, intelligent service, can become more and more intelligent, right? By collecting more and more data and have more adjustment or more improvement, right? So this is a continuous cycle for improvement. So data from IoT devices and sensors saved or stored on the cloud, on the big data umbrella, and the big data is trained by AI or machine learning and sends command to IoT device, right? This is again continuous cycle. Now, as more and more IoT devices are interconnected, at the same time, more business processes are transformed by blockchain. The blockchain platform is integrated into IoT platform, right? So IoT, blockchain, and artificial intelligence will be integrated together. So as we are moving into hyper-connected society, this integration will become more major, right?
A digital revolution is currently underway. We see signs of it in every aspect of our society. education, medicine, farming. Cryptocurrencies are disrupting banking systems in our physical world. Energy grids, communication, transportation systems, our homes and places where we work are all connecting to the virtual world in the cloud.
How can we stay on top of these changes? How can we position ourselves and our organizations to take better advantage of the opportunities available to us?
Hi, my name is Abel Sanchez. I am the Executive Director of MIT's Geospatial Data Center, and I specialize in the Internet of Things, Big Data, cybersecurity, and digital innovation.
My name is John Williams. I'm a Professor of Information Engineering at MIT. I'm also Director of MIT's Geospatial Data Center, and I specialize in large-scale computing and analysis applied to the Internet of Things, cybersecurity, and information technology.
My colleague John Williams and I have created this course on digital transformation with the aim of better equipping working professionals from across disciplines to sort through this jargon, the misinformation, and the hype that we often see around this phenomenon. Together we will explore 5 digital foundational aspects of transformation. First, blockchain. Cryptocurrencies are transforming banking and commerce. But it is blockchain technology, an immutable online ledger system, that makes cryptocurrencies possible. We'll take a look at the history and evolution of blockchain and at cryptocurrencies and the impact that they will have for individuals, for industry, and for government.
We'll review the innovations in artificial intelligence and what this means for the future of work. Right now we have machines translating languages, working on assembly lines, and operating farming equipment and mining equipment. In every industry, the use of machines is transforming how work is done. We'll talk about what you need to know to stay current and leverage the opportunities these innovations present.
The Internet of Things. Every day, more devices are connected to the World Wide Web and to servers owned and managed by services like Amazon Web Services Cloud. We'll explore what this means to you, for your customers and your competitors.
We'll also look at the cloud, which is not so much an actual location as it is a model for using computer technology.
Innovations in cloud computing are moving us from the relatively simple notion of software as a service to everything as a service. Using the cloud, companies can be up and running in very little time with serious computing power and almost no physical computing infrastructure.
Our increased reliance on digital infrastructure also means a greater need to protect it.
Our module on cybersecurity gives an overview of the threats we're facing and the quantity and quality of those threats. We will help you prepare to think about how to build teams and processes to defend yourself and your company. In addition to the practical knowledge that you will gain from our video lectures, you will also learn from live webinars with faculty, peer discussions, and interactive hands-on assignments. We will create a cryptocurrency, build a worldwide service, and hack a password.
Throughout the program, there will be experienced learning facilitators to guide you and to respond when you need more clarification.
At the end of the course, you should be able to understand how digital technologies can help your organization stay relevant and competitive. Come join us for an action-oriented guided tour through the foundations of digital transformation. We're excited to help you develop a better understanding of these topics and how they can be applied across industries and disciplines.
There will be 100 billion connected devices all over the world by 2025. With so many digital connections, the future of an intelligent world, where all devices and people are connected, is not far away. Technology like big data, IoT, AI and cloud are the key ingredients for building an intelligent world, where smart cities, smart factories and smart homes will act as an ecosystem alive with mass customization and personalization at your fingertips. And data and networks linked to the cloud with high-speed connections that grow and change with us every day. Organizations are responsible for creating this vision, and in order to be competitive, moving into the future, understanding the role of technology and how to use it will shape the intelligent world. Building an intelligent world is not without its challenges. And the true question for CEOs and CIOs and executives from organizations all around the world is how I can make data-driven decisions in real time. I was invited to attend Huawei's Global Analyst Summit 2018 in Shenzhen, China, and I witnessed a presentation where Huawei rotating CEO Eric Xu helped to lay out the blueprints for his vision of an intelligent world. So I asked technology expert Dr. Greg Brown to help us understand how Eric Xu's vision of an intelligent world can be created.
Well, AI is one of the key ingredients here because, okay, the data is being generated from all the devices that are now connected. But you got to have something that understands the data, right? Because the users aren't necessarily telling you what the data is for. The data is coming out of these devices. The intelligence, the artificial intelligence, is now understanding what to do with it. And it's the key ingredient to making it actionable. Without the artificial intelligence, there isn't any way to truly turn it into insights into action. With machine learning comes the insights and the intuitiveness of understanding what to do with the data and what are the lessons learned. And then what we do next time situations or what the data tells us to do occurs.
It all begins with IoT devices that are generating massive quantities of data. The clouds make all of this data accessible, and the data is too often kept in storage, processed at a separate location, eventually traveling to the CEO or the CIO, where it's used to make intelligent decisions. But instead, this data needs to be read from inception all the way to the point where it lands, giving organizations the means to truly read and understand data-driven information in real time. And this is where artificial intelligence and machine learning technology comes into play. Big data, IoT, and AI are the key ingredients for building an intelligent world. If organizations can respond to the fast-growing pace of technology demands by understanding how technology can be used to make real-time decisions, they will help to shape the intelligent world. I would like to thank Huawei, Eric Xu, and Dr. Greg Brown. I'm Ronald van Loon, and this is the Intelligent World. Enjoy this.
All right, here are some review questions. I strongly suggest you to go over these questions to understand basic concepts of the lecture, right? Kata rahmat. Spasiba. Thank you.